Washington Middle School, welcome to your third week of school. It is so good to be with you. I hope you had a wonderful Labor Day weekend, as I did as well. So last week we worked with ratios. We learned how to compare numbers using a ratio, two numbers that we can compare. Then we looked at equivalent ratios. Today, our standard is this. I can represent a collection of equivalent ratios as ordered pairs and graph the ratio relationship on a coordinate plane. So what does all that mean? Well, to get that, we need a little bit of vocabulary. Coordinate plane. That is a grid pattern. So you have lines vertical and lines horizontal, and you have a coordinate plane. We're going to show that in a little bit. Ordered pair is a number and then another number. What does order mean? Yeah, it always goes the same order. It doesn't change, and a pair is two. All right, origin. What does the term origin mean in your everyday life? Yeah, the things that are where something begins. The start is the origin. So you're going to have an origin on a coordinate plane, where something starts. X-axis. Have you ever heard the term axis before? In math, the x-axis is the horizontal plane. The flat one is the horizontal plane, is the x-axis. X-coordinate. In the ordered pair, 4, 6. Which number is the x-coordinate? That's right, the 4 is the x-coordinate. The first one is always the x-coordinate. All right, y-axis. In math, where's the y-axis? Yeah, remember, that's that vertical line. The line that is straight up and down is your y-axis. And then y-coordinate. In the coordinate pair, ordered pair, 5, 7. Which number is the y-coordinate? Yeah, it's a 7, because the 7 is the second number, is always in that order. The order is y, is the second number. Ratios as ordered pairs. You learned last week how to create a ratio table and extend it by finding equivalent ratios, which is exactly what we have right here. You can also represent a ratio relationship by creating a table of ordered pairs and graphing the ordered pairs on the coordinate plane. So to make a simple salad dressing, you can use 3 cups of olive oil for every 1 cup of vinegar. You can then add herbs and salt and pepper for seasoning. The relationship is shown in the table. Each pair of equivalent ratios can be expressed as an ordered pair. The x-coordinate, the horizontal coordinate, represents the number of cups of vinegar. The y-coordinate, the vertical coordinate, represents the number of cups of olive oil. All right, so I'm going to go to the next page right up here. It's got the arrow, says 1 of 3. I've got to be careful. I can't go down to the next resource until I've gone through each of the pages of this resource. To graph a point, you start at the origin. Where's the origin? Yeah, right down here. 0 on the x-coordinate and 0 on the y-coordinate is our origin. So move right along the x-axis, the number of units indicated by the x-coordinate. From that location, move up along the y-axis, the number of units indicated by the y-coordinate. Place a dot at each location. So our first ordered pair is 1 cup of vinegar for 3 cups of olive oil. So I'm going to go down here. I'm going to add a dot, and I'm going to put that at 1 cup of olive oil. Is that right? 1 cup of vinegar for 3 cups of olive oil. I'm going to put it right there. 1 cup of vinegar, 3 cups of olive oil. The next pair is 2 cups of vinegar and 6 cups of olive oil. So 2 cups of vinegar on the x-axis and 6 cups of olive oil on the y-axis. So 2 on the x and 6 on the y. Now I'm going to put another one, and you can just see where that's going, but I can see it here, 3 and 9. 3 cups of vinegar on the x-axis and 9 cups of olive oil on the y-axis. Going to go again, 4 and 12. And you can see where this is going. I'm just going to add that. We'll speed this up, 4 and 12. And the next one is going to be, well, if the last one is 4 and 12, then 5, 15 is the last one. And these show 1, 3, 2, 6, 3, 9, 4, 12, 5, 15. And we have a line that is our equation. I need to move my video over, check the answer, and it says correct. I got it. So now I'm going to go to the next page up here, page 3 of 3. So now talk about it. Compare and contrast the ratio table and the graph. How do they both illustrate the same ratio relationship? I want you to think about that. And maybe show a parent, show your brother, show your sister. How do these both illustrate the same ratio relationship? Now, how does the graph help you to visualize the ratio relationship? Let me think about that, and maybe talk to your parents, talk to your brother, talk to a sister. How does this graph right here help you to visualize what you see in the table over here? Because getting a visual is so important in math that we can understand things visually. All right, the next example. Tamara is making charm bracelets for several friends. She uses 6 beads for every charm. So generate the set of ordered pairs for the ratio relationship between the number of beads, y, and the number of charms, x, for a total of 1, 2, 3, and 4 charms. Then graph the relationship. Okay, so I know that she is using 6 beads for every charm. Create a table of ordered pairs. Let the x-coordinates represent the number of charms, and the y-coordinate represent the number of beads. So I know that for one charm on the x-coordinate, I have 6 beads. Well, if I have 2 charms, then how many beads am I going to have? Yes, right. I'm going to have 12, because 1 times 2 is 2, and 6 times 2 is 12. I can see that right here. How many am I going to have for 18? How many beads do I have for 3 charms? Yeah, 18. I already said it. You can fill this out on your own. All right, so you need to complete every page of your presentation. Make sure to go through all of the pages of the resources in your presentation. Then click on next resource till you get through the presentation. When you are done with that, take your practice quiz and then take your exit ticket, and you are done until Thursday and Friday. We've got our next activities. Have a great day. I will see you in class.